Here we have a problem to find area of the region that lies inside the first curve but outside the second curve. So first of all, I want to see what my outside graph looks like. So I'm going to put it in my, remember, I need to change mod to polar and then hit Y. I'm going to write 4 sine theta and I'm going to see the graph of that. That graph is a circle with center at y-axis and the radius as 2. Okay. Now I'm going to go back and in the second equation, I'm going to put my second graph, which is r equal to 2. So I see that graph. That's the red graph, which is centered at 0, but the radius is still 2. Okay, so we need to work on this graph. So here I have my graph here. This blue graph is the first curve, r is equal to 4 sine theta. And this red graph is r equal to 2. My question is to find the area of the region that lies inside the first curve but outside the second curve. So only portion which we need to find is this portion that is inside the first curve but outside the second curve, which is the red curve. We don't want to go inside the second curve. Okay, this is the highlighted portion. Now, the first order of business is I do not know from where to where the graph area has to be found. Okay, so I would need to find the intersection points. Intersection points are easy to find if you equate the equation. So basically 4 sine theta, the first equation is 4 sine theta equal to 2. That means sine theta is equal to 2 by 4, which is half. When is sine theta half? Theta at pi by 6 and 5 pi by 6. Therefore, at this point, we can see it's in the first quadrant, theta is pi by 6, and this point, theta is 5 pi by 6. So we need to find this area from theta pi by 6 to theta 5 pi by 6. You know what? I like to use symmetry. This graph is symmetric with respect to y-axis. If I just find this portion and double it up, that should be good enough. So to find the red area, I need to do top graph minus the lower graph. What is the outside graph here? The blue graph. So the formula is area is equal to whatever alpha to beta you want, half f of theta. F of theta is the larger graph, which is on the top, minus g of theta square, which is the lower graph. So let's write the area formula. It's going to be half from 0 to pi by 2 f of theta square, which is outside square, that is 4 sine theta square. So that is going to be 16 sine square theta minus the inside graph is 2. So that is 2 square, which is just 4 with respect to theta. But now I'm only integrating, not from 0, from pi by 6 to pi by 2. And that is only the red area. But I need to find the whole highlighted area. For that, I need to multiply this by 2. And this 2 and 2 gonna cancel each other. We only need to find the integral to find the area. Okay, now we know we easily can integrate 4, but for sine square theta, we need to convert that into our formula. Sine square theta is 1 minus cosine double theta by 2. So that's a double angle formula which we're going to use. So let's write integral from, I keep writing 0, it's not 0, pi by 6 to pi by 2, 16. In place of sine square theta, we are going to write 1 minus cosine double angle by 2 minus 4, okay, d theta. I'm almost ready to integrate, but I want to simplify it one more time. 16 by 2. This is gonna cancel. 8 multiplies inside. 8 minus 8 cosine 2 theta minus 4 d theta. Do you guys notice this 8 minus 4 can be just replaced by a 4 here. So we have this integral. What is the integral of 4? 4 theta. Minus integral of cosine is sine 2 theta by theta. Once you're done with the integral, the limits are written on the right hand side. This 2 can cancel 4. So now we need to put upper limit minus the lower limit. Okay, so let's try that. 4 times pi by 2 minus 4 sine 2 times pi by 2. 4 times pi by 6 minus 4 sine 2 times pi by 6. Okay. This is 2 pi. This term is going to be sine pi, which is going to become 0. Okay, gone. This is minus 2 pi by 3 because the negative outside. This is sine pi by 3. Negative, negative plus 4 times sine pi by 3 is root 3 by 2. 2 pi minus 2 pi by 3 is 4 pi by 3 and plus 2 root 3. That is your area of the highlighted portion which we needed to find inside the first curve, outside the second curve.